Download this code from codegive.com, link in the description below. Adding a cache to an application can significantly improve performance, but it requires careful planning and implementation. Caching is not just about storing data, it's about ensuring that the right data is cached, invalidating outdated data, and managing cache size and performance. Below is an informative tutorial on how to add caching to an application, along with a code example. Overview of caching. What is caching? Caching is the process of storing copies of files or data in a cache, temporary storage location, so that future requests for that data can be served faster. Why use caching? Performance improvement, reduces the time taken to access data. Reduced load on backend services, less frequent calls to a database or an API. Cost efficiency, saves on computational resources. Steps to implement caching. 1. Identify what to cache. Not all data should be cached. Focus on frequently requested data or expensive computations. Consider the size of the data and the memory limits of your cache. 2. Choose a caching strategy. In-memory caching, fast access, example readies, MEMC8. Disk-based caching, for larger data sets that don't fit in memory. 3. Implement cache logic. Store data in the cache when it's first retrieved. Retrieve data from the cache on subsequent requests. Invalidate or update the cache when the underlying data changes. 4. Handle cache misses. If the data is not found in the cache miss, fetch it from the original source and cache it. 5. Monitor cache performance. Track cache hit/miss ratios, cache size, and expiration policies. Code example, implementing a simple cache. Let's implement a simple in-memory cache in Python using a dictionary. This example will simulate caching database query results. Example, simple cache implementation. Python. Import time. Class simple cache. def__init__, self, expiration_time equals 60. Self.cache equals. Self.expiration_time equals expiration_time. Def get, self, key. If key in self.cache. Value, timestamp equals self.cache key. Check if the cache is expired. If time.time, timestamp self.expiration_time. Print, cache hit. Return value. Else. Print, cache expired. Self.remove, key. Print, cache miss. Return none. Def set, self, key, value. Self.cache key equals, value, time.time. Print, f cached key, value. Def remove, self, key. If key in self.cache. Del self.cache key. Print, f removed key from cache. Simulating a database call. Def fetch _data_ from _database, query. Print, f fetching data for, query. Time.sleep, 2, simulating a delay. Return f result for query. Using the cache. Cache equals simple cache, expiration_time equals 10, cache expiration time is 10 seconds. Def get _data, query. First, try to get the data from the cache. Cached_result equals cache.get, query. If cached_result. Return cached_result. If not in cache, fetch from the database. Result equals fetch _data_ from _database, query. Cache.set, query, result. Return result. Example usage. Print, get underscore data, select asterisk from users, fetches from DB and caches. Print, get underscore data, select asterisk from users, fetches from cache. Time.sleep, 11, wait for cache to expire. Print, get underscore data, select asterisk from users, fetches from DB again. Explanation of the code. One simple cache class implements a basic caching mechanism using a dictionary. Stores values along with their timestamps to check for expiration. 2 get method checks if the key exists and if it's still valid, not expired. Returns the cached value if valid, otherwise indicates a cache miss. 3 set method adds a key value pair to the cache with the current timestamp. 4 fetch underscore data underscore from underscore database function simulates a time-consuming database call. 5 get underscore data function tries to get data from the cache first, otherwise fetches from the database and caches the result. Conclusion. Adding a cache to your application is not straightforward and requires careful consideration of the data to be cached, cache invalidation strategies, and monitoring performance. The example provided demonstrates a basic in-memory caching mechanism in Python, which can be expanded upon or adapted to use more advanced caching libraries or systems like Redis or MEMC8 for production-level applications. Always remember to test and validate your caching strategy to ensure it meets your application's needs.